Topic for the today's video is recursion. A function calling itself is known as recursion. For example, we take the example of factorial. Suppose we wanted to calculate the factorial of 6. Suppose we take 6. So in order to calculate the factorial of 6, we need to know the factorial of 5. So what we will do, we will calculate the factorial of 5 and we will multiply that with the 6. Again, what we can do is we will calculate for factorial of 5, we have to calculate the factorial of 4, and we will multiply that 5 with the factorial of 4 and we will get the value. Simply for calculating the factorial of 4, we need to know the factorial of 3, and we multiplied 4 with the factorial of 3. Again, following the same, we will wanted to calculate the factorial of 3, we have to know the factorial of 2 and we will multiply it by 3. Now again, moving to calculate the factorial of 2, we need to calculate the factorial of 1, that is, and we will multiply it with 2. And now here we can terminate the function here. As we know that the factorial of 1 is 1, so we can calculate this and we will compute the value of this function, that is 2. We will put this 2 here, that is we will calculate the value of this, that is 6. Now we can put the value here, this 6 value we can put here. We will have 24. Now we can put the factorial of 4 here, that is 24 into 5. Now we can calculate it to 120 into 6. So 120 into 6 is nothing but 720. So in order to calculate the factorial of 6, what have we do or what we have done is we have repeatedly calculated the values of previous factorials. So the factorial, as we know also, that factorial of n factorial, we can write it as n into n minus 1 into n minus 2 dot 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 up till 2 1. This we also know that n factorial is n into factorial of n minus 1. Okay, so now if we write the following condition, following solution or following approach as a program, so what we will write, if we wanted to calculate the factorial of 9n, what we will do, we will compute repeatedly the values. For example, f of n minus 1 into n for 1, for n equals to 1, we will simply print the or return the output as 1. So if n is equals to 1, what we will return, we will return the value 1 unless uh, we will return f n into f of n minus 1. This is the recursion program for the factorial. So now we can also see how this program, uh, we can also analyze more into this recursion by taking the same example. So every recursion will have the termination state. Okay, this is a termination state for the factorial program. If we don't have the termination state, we will get an exception of stack overflow if we won't have the termination condition. Have termination condition, we will suffer from stack overflow. So this is a point to remember. So every recursive program must have a termination condition in order to stop the program or the things. So if we wanted to dive more into the recursion, so what happened in the above program is this. Recursion always uses the stack. So when we calculated the factorial for 6, what we have done is we have created a stack, for example, in the memory, and we have pushed the function into the stack. So we have f into this into the stack for the first pass, and then we will again do calculation for f5. F5 is nothing, is f into 4 into 5. We will push again the value for f4, that is f of 3 into multiplied by f of 4. Again diving deep into this, f into 2 and 2 into f into 1, and then simply returning the value 1. One of the basic property of a stack is it always, what does it, LIFO. LIFO means last in first out. So the function that is insert pushed in the last will be executed first. So first one will be returned back to the function, and then f1 will return this, f2, and then f3 will return, and then f4 will return, and f5 will return, and generating the result 720. This is what we have done in the above example. So in order to solve this problem by recursion, we use stack. Stack recursion can also be defined as solving the big problem into the smaller problem. Solving the big problem into or in terms of, let me write, in terms of small problems. What we have done in the above example, we have a big problem. Suppose we wanted to calculate the factorial of f6. We repeatedly broke down that problem into the smaller problems, and that smaller problems we can easily solve. And when we solve these smaller problems, we are able to generate the result for the big problem. So, and one more thing, the space complexity for the recursive program the is order of the stack space. So in the program we have order of n for the stack space. Okay, we can also write the recurrence relation for the above program. How can we write? We have, if n equals to 1, we just simply return the value as 1, and when n is greater to 1, we simply multiplied it and return the function with the n minus 1. So this is it, and every recursive program can be written by using non-recursive program, and that is also possible. And this is all from this topic.